Hello, 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 everybody, and welcome back. Root Beer here, and I'm in the middle of part C of the 2019 Cayley paper. We're halfway through. We've got question 23. That's what we're going to be looking at in this video. So we've already done 2 in part C. We'll have 2 more to go after this video. So what have we got for question 23? And it's a question that looks very similar to one of the Pascal paper questions. Maybe it's a little different. A path of length 38 meters consists of 19 unshaded stripes of length 1 meter, alternating with 19 shaded stripes of length 1 meter. Yeah, we had this question. I think it was 12 meters and 6 or something like that. But we had the same sort of setup. I remember the same picture with the Pascal because I recorded it earlier today. But what have we got? A circular wheel of radius 2 meters is divided into 4 quarters, which are alternately shaded and unshaded. The wheel rolls at a constant speed along the path from the starting position as shown. The wheel makes exactly 3 complete revolutions. I think it was only 1 on the Pascal, which would make sense because the Cayley question should be harder. I'm going to stop referencing the Pascal now and just treat it like a normal question. The percentage of time during which the shaded section of the wheel is touching the shaded part of the path is closest to, and we have a number of percents. Okay. So what are we going to do? Well, let's first understand a bit more about this wheel, because certain parts of it, as we roll, imagine it's covered in blue paint. As we roll, it'll slowly transfer the paint down here. Okay, so as we roll, the shaded part here will match up with parts of the path, and then we'll get to the unshaded part, and that'll take over after a while, and then we'll be back to shaded once this part has rolled all the way down. So basically, the wheel is creating its own shaded, unshaded, shaded, unshaded, shaded, unshaded path, just like the path here, and we just want to see how much is overlapping. Okay. And to figure out the percentage, we're going to need to know how far does it go with 3 complete revolutions. So let's understand the wheel a little bit better. It said 2 meters. Is 2 meters the radius? Radius 2 meters, okay. So 2 meters is the radius. That means the circumference is 2 pi r, and that's going to be 4 pi meters. Okay. So the shaded area that will come in contact with the path, there's pi of it here, pi unshaded, pi shaded, pi unshaded in terms of the segments. So what's going to happen is we're going to sort of get 2 paths almost. We're going to get, draw it a little smoother than that. So we've got our normal path that's going, does it start shaded or does it start unshaded? Starts unshaded, so I'll let red be unshaded since that's what I was doing before. So it's unshaded, and I probably need more than that. And then it's shaded, whereas the wheel, as it sort of unspools, starts out shaded, and it's shaded, 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 and then it stops being shaded after it's gone pi, after pi of its circumference has gone, and then it starts being unshaded again. Okay, so where do these transitions take place? Well, if we number sort of a number line here, we can see that the path starts being shaded at every odd number, and it starts being unshaded at every even number. The path traced out by the wheel, or painted by the wheel, however you want to view it, starts out shaded and starts being unshaded at odd multiples of pi, and then it starts being shaded again at even multiples of pi. So technically, we got 0 pi over here. Okay. Now, writing them out with pi's, 2 pi's, 3 pi's, while that's all very well and good, I think it's a little easier just to grab your calculator and use a decimal approximation. If you don't have a calculator, just go with 3.14. That should be close enough for our purposes. So we'll have 0 to about 3.14, to about 6.28, to about 9.42, and so we can start making a very nice, simple little number line here. I'll start over here. So 0 to 3.14 to 6.28 to 9.42 to 12.56. I'm just going to double check that that is right. Yep, 12.56. So that's one revolution. I'm going to cut it off there just to make my life a little easier. We'll start it again down here. So 12.56. 15 something, I'm sure. 15.7. 18.84, so that would be 6 pi as unfurled. And then 21.98, and then once more. So after 8 pi, we are at 25.12. So let's again bring that down here just for the sake of having a nice, easy to work with picture. So 9 pi is at 28.26. 10 pi, we'll say about 31.4. 11 pi, 34.54. And finally 12 pi, which is the total of 3 rotations. Because each rotation, each one of these lines represents one rotation, is the circumference of 4 pi slowly unraveling or being painted across the surface. So there we go. We start shaded, 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 shaded. All right. Now, I don't know, we'll use purple. Where in this first segment is the path shaded? Well, from 1 up to 2, and also from 3 up to 4, but we don't really care about the up to 4 because we stop having overlap when we hit pi. So we've got 1 and pi minus 3. That's the distance in this first shading that overlaps with the paths shading. How about over here after 6.8? Well, the next time we're shaded is 7 to 8, and then 9, just for a little bit. I know it's supposed to go 9 to 10, but we only go up to 3 pi. The wheel stops shading at that point. So we have 1, and then we've got 3 pi minus 9. Fine. All right, now we're shading again, starting at 12.56, but we're unshaded, because before that would be 12, and you're unshaded from 12 to 13. But then 13 to 14, absolutely shaded, and then starting 15 going up to 16, it's shaded, but the wheel stops shading at 5 pi. So we'll have another 1 and then 5 pi minus 15. Same thing down here. You'll notice that we keep getting 1 and then a little bit. That does actually stop, I believe, down in the next layer. Makes the question a little harder, so you don't just keep assuming it's the same pattern over and over again. Anyways, 18, so 19 to 20 were shaded. And then 21 to 22, but we only count a little bit. So we get a distance 1 where it's overlapped, and then 7 pi minus 21. All right, now, here it's about to change. So we would start at 25.12, and you'd think, 26 to 27, except no. The path starts being shaded at 25. I've been using purple, haven't I? So it starts being shaded at 25. So we're actually shaded as we come into here, and we stop at 26. So there's a partial shading here, and then 27 to 28. So we get 1. We also get 26 minus 8 pi. That's what this little segment over here is. Same thing down here. 31 up to 32 is shaded. So just a tiny little sliver of 32 minus 10 pi. 31.4 is 10 pi. And then 33 to 34 gives me another full overlap of 1 meter with 1 meter of the circle. And that's it. That's all it is. But it's a lot to keep track of. And the fact that it switches down here, I think, might have caused a number of people some problems. So we've got 1, 2, 3, 4, 5, 6 ones. And then we've got pi, 3 pi, 5 pi, 7 pi, minus 8 pi, minus 10 pi. And then we've also got minus 3, minus 9, minus 15, minus 21, plus 26, plus 32. All right, so let's simplify that. So that's 6 plus 8 pi, 16 pi minus 18 pi. So 6 minus 2 pi. And then 24, another 24. So 48 is what we're subtracting off, and that's 58. So 58 minus 48 is 10. So the total amount of path that's shaded while the shaded part of the wheel is touching the path is 16 minus 2 pi. Now we want the percentage. So how much does the wheel actually cover? Total of 12 pi. And we multiply that by 100%. So we just grab our calculators. And if you don't have a calculator, of course, use the approximation 3.14. 16 minus 6.28 is about 9.72. Divide that by 12 pi, which 37.68. So 9 out of 37, we're looking about 25%-ish, maybe. But we've got a calculator, so let's make it exact. So 9.7168 divided by 12 times pi, 37.6991. So 25.7% approximately. I think it was even numbers. They wanted us close to. It's closest to 26, and yeah, there it is. E. That's about 26%. And that's E. So there we go, all tucked away. Now, as I said at the start, very similar to the Pascal question. I did do that, so if you want to take a look at the 2019 Pascal question, I don't know which one it was. It might have been 23. I'm pretty sure it was in part C. But it could have been something like 21 or 22 as well. But yeah, very, very similar. This one took a little longer. And of course, there's that nice little twist where the shading pattern doesn't quite follow the same. But yeah, we managed to get a nice little answer of E there anyway. So up next, we're going to be looking at 24 on our Cayley contest. So I will see you for that if you're interested. Until then, take care.